Assignment 1. Power and power factor measurement in single phase circuit. Hi, first we draw the circuit. Choose the AC power. Then change the voltage RMS to 200 VRMS. Add grounding. Then add 910 ohms resistor into the circuit, multimeter, and add the wattmeter. Next, make connection to all the components, to the multimeter and the wattmeter. Make sure the connection is correct. Connect the resistor to the multimeter and the wattmeter. Then, we run the circuit and read the value of current, power, and the power factor. This is the current table. So drag here. So here the power value is 43 something and the power factor is 1. That means it's good. And the current value 219.772 milliampere. Next, we change the resistor to 1.8 kilo ohms. And write in it again and see the result. So the power is decreased, but the power factor value is remain the same. And the value of the current also decreased to 111.104 milliampere. Next, we change the resistor to 3.3 kilo ohms. Run it. As we can see, the value of the power also decreased while the power factor is still same like the previous one. So, this is the value of the current also decreasing. To conclude, the resistive load circuit have zero angle and less power loss because the value of the power factor is 1. So we proceed to the resistive inductive RL load circuit. So we add the 2 Henry of inductance here, rotate, make the connection to the resistor. We need to change the value of resistor back to 9.0 ohms. Run. We can see the value of power is increasing and the value of the power factor is below than 1. So this is the current value for this circuit. Stop. So we change the value of inductance to 3.9 Henry. And the value of the resistor to 1.8 kilo ohms. Run it. We can see the value are decreasing for both power and current, but the power factor still below than 1. Then we change the resistor to 3.3 kilo ohms. And the inductance 8.2 Henry. Then stop. The value of the power and the current also still decreasing. Alright. So to conclude, for this RS circuit, it have an angle. If the current lagging to the voltage, so the power factor also lagging. Lastly, we go to resistive capacitive RC load circuit. add 1 microfarad, connect to the resistor, change the resistor value and run it again. As we can see, the value of the power factor is nearest to 1, so it is good because it's 0.9 something. Okay, the value of current is 232 something milliampere. Then we change the capacitor to 2 microfarad and the resistor to 1.8 kilo ohms. Run it. So we can see the power factor value is 0.5 something, and here the current result 188. Okay, the lastly, change the capacitor to 3.9 microfarad and the resistor to 3.3 kilo ohms. Run it to see the result. Okay, we can see the value of the power is decreased and the value of power factor is decreasing. It nearest to zero value. That means it have high power wasted. This is current value. Okay, in the conclusion, for this RC circuit, we know that current leads to voltage by 90 degrees. Conclusion. Thank you.